Okay, here's our video on adding and subtracting in scientific notation. Now when we add in scientific notation or subtract, it's very important that the exponents are the same. So you can see right here the exponents are not the same, so we have to make them the same. Now there's two ways we can do this. We can do it the short way or the long way, and most students actually prefer the long way. So I'll do the long way in this video, and then in the next video I'll show you a shortcut. For some reason, most students just prefer doing it the long way. And in the long way, you're just going to make each of these numbers, you're going to go from scientific notation to standard form. And then you can put it back into scientific notation if it calls for. So for example, here, we know that if you see a number by itself, there's always a decimal there. 2 is actually 2.0. Same with the 3. There's a decimal there. And the exponent is telling us, if you remember, to move it 4 times. So the decimal tells us everything to do. So we have 4 empty waves. Anytime you have an empty wave, we're going to put the zeros. So we have 20,000. Same here. We're going to move this now 5 times. The exponent says 5 times. 1, 2, 3, 4, 5. Right? So we should have 5 zeros. 1, 2, 3, 4, 5. 300,000. So we just add 300,000 plus 20,000. And you get 320,000. So that's the answer in standard form. Now, if you find on a test or on a state test where they say put the answer back in scientific notation, well, here we have it. Let's write it again. This is the answer in standard form. And you remember, in scientific notation, you have to have one number, and there has to be a decimal before you put the next number. So here we have it, and we're going to just do it times 10. We never put zeros unless a zero comes before any other whole number. So we have 3.2 times 10. Now, to find out what exponent we put, remember, this is where the decimal is. How can we get it back there? How many times are we moving it? 1, 2, 3, 4, 5. There we go. There's our answer. 3.2 times 10 to the 5th. So let's do a couple more so we understand it. Okay, so let's look at this problem. So when you see a negative exponent, remember, we have to move the decimal to the left. So here's the decimal here, and we're going to move it 3 times. 1, 2, 3. So it's going to be 0.002. Putting it in standard form. And over here it's saying do not move the decimal at all. So it's just 3. So our answer would be 3.002. And it's actually in scientific notation already, because remember, you have to have the number, the decimal comes right after the first digit. So it's already in scientific notation, so we put a 0, because anything to the 0 power is 1. So there's the answer. Okay, let's try this one now. Put them in standard form, and then put it back in scientific notation after you get the answer. So what is the first thing you do for this one? Again, the decimal's there. Just move it 3 times. So from here, you would go 1, 2, 3. So you get 0.005. Now this one is telling us to move it 3 times. 1, 2, 3. So you have 3 zeros. You'll have 6,000. So the final answer will be 6,000.005. Okay. Now this is not in scientific notation. Remember, after the first digit, we put it in scientific notation. So what exponent do you think we should use? So again, if the decimal was here, we had to move it 3 times. Since the decimal is here, we want to go back to what? To there. So 1, 2, 3 times. And we get the same answer. 1, 2, 3 times. So it would be 10 to the 3rd power. Okay? Let me write that again so you understand it. Bring this up. So we had 6,000.005 in scientific notation, we use the first digit, right? And we have to put all the zeros because there's a 5 at the end. So it's going to be 6.000005 times 10. Now, we're here, but we want to get here. So we're 1, 2, 3 away, 3 zeros away. So it's 10 to the third power. Bring that up a little. Let's try one more. Erase this. What if we had, over here, 7 times 10 to the second power plus 3 times 10 to the negative first power? Try that. Well, here it's telling you to move the decimal twice, so that's 700. And here it's telling you to move back 1, so it's 0.3. So it's 700.3. That's in standard form. So in scientific notation, remember the first digit, then the decimal. 003. You have to put the zeros because there's a whole number at the end. It's greater than 0. Now, how many times should I move this decimal so we can get this answer right here? We want that decimal there, so we move it 1, 2, twice. There's the answer. Scientific notation. And remember, when you move the decimal, just erase that out of the way so you see it better. Okay. So we move this decimal twice to get the same answer. There's one thing we forgot. We forgot subtraction. So let's say we had, put one over here, 8 times 10 to the third power, and we'll minus it this time. And we'll minus it to, let's say, 9 times 10 to the negative first power. There we go. Well, let's just keep it positive for now. Let's say the fifth power. Okay. So again, the same principle, same thing, just have a minus sign. Just remember the minus at the end. So we're moving this. We have an 8, so we should have 3 zeros here. That's 8,000. And we're going to minus. Now we have 5 zeros here. So we'd have 1, 2, 3, 4, 5. Bring that over. Just bring this over. So it's 8,000 minus 900,000. Remember, the 8 times 10 to the third came first, so you have to do that one first. So we know this is going to be a negative answer. We know we're going to have a negative answer. So if you get confused, you can put the 900,000 on top and subtract, and that'll be your negative answer. So if you want to do that, you can put the 900,000 on top and minus it by the 8,000, and you'll get your answer. So we'll have a negative 892,000. That'll be the answer with subtraction. So it's the same rules when you're adding and subtracting. Just make sure you subtract. So don't get fooled with that. Great job.